Okay, hello everyone. Welcome back to another Nabu PC episode. Today we are doing a low-level sort of Hello World exercise using the USB to serial or USB to TTL adapter that I did show in my previous video. So what I did last time is I had this small adapter that goes from USB to TTL serial connectivity, and I showed you how you can get this hooked into your Nabu. So this avoids the problems with voltage levels on a RS422 adapter that you typically get for Nabu. It can do it natively, talking a 5-volt TTL in and out of Nabu. So with this in place, having this piece of hardware, what we want to do is we want to somehow use this hardware, for something useful. So as a starting point, I use the amazing software that the team from nabu.ca has published, DJ Search and the gang. They've done an amazing work. They released all this software. He's still working on improvements. So we really appreciate their hard work. So that's one of the ways of using your Nabu once you have the connectivity, serial connectivity in and out of the computer. In his videos, he's also suggesting, of course, doing homebrew, so writing code and developing for Nabu. My interest would be also to develop code bare metal, so without using any of the Nabu infrastructure or any of the Nabu operating system. How can we get code in and out? I did show you videos before where you can, use either just pure EEPROMs or EEPROMs or an EEPROM emulator, but I know not everyone has got access to EEPROM emulator, so there is a third way. And that third way is to have to replace the operating system of the Nabu with some very simple resident operating system that typically is referred to as a monitor software. This monitor software is similar to what an Arduino is doing, where there's a small bootloader waiting for serial connectivity at the very beginning, just after reset. It's waiting for serial connectivity, and once that serial connectivity is up, what you can do is you can upload your code and it will execute the code that you uploaded. So that's what we're going to try and do today. The work that I'm going to be basing today's demonstration on is, I don't know who that person is. Random Variations is his GitHub repository. Whoever this person is, he's done or she's done an amazing job for Nabu, because this person has managed to get CPM booted. This is booted over serial connectivity, so not yet on the video, but this is a fantastic work that has been done. So what I'll borrow from this work, and I'll share obviously the links and everything, what I'll borrow from this work is this monitor.hex. That's a file that is the actual resident monitor that you can program into the Nabu. So what you do is you replace the ROM of the Nabu with an EEPROM or another EEPROM with that monitor hex programmed. One of my previous videos, you will see how I swapped the EEPROMs in Nabu, so you can use the same procedure, and you replace the original Nabu firmware with this monitor firmware. So with this in place, with this replacement firmware, what you get is I'm right now connected to my Nabu over serial connection, and this resident monitor, this is all done. I mean, the actual code of the resident monitor it was released by Grant Searle years ago. This has been around for quite a while for Z80 based systems, and this person here has adjusted that monitor to make it work with Nabu. So that what that allows us to do is allows us to upload. So there's a command to upload to upload code in an Intel hex format. So that's what we are, what we're trying to do. Get some Intel hex format software and upload it into Nabu. How can we get this software? Well, of course, we need to create some software in assembly, but again, fantastic job, the Nabu team from nabu.ca. They shared the simple hello world file. You can download that file. By the way, I'll share also all the stuff that I'm showing you today. I will share on GitHub, so you have one place to download all of this from. But what I'll show you here is a couple of files. So the file that I downloaded from nabu.ca is this large file here. And what it does, it has, the Hello World demo that they developed and a bunch of knobs. I don't remember what those knobs were for. I assume that this is to make the file correct size to work with the software adapter. Remember the software adapter that has been published by the nabu.ca team? It also allows to upload your own code into Nabu, but we want to bypass this and we just want to do a bare metal, sort of, more closer to the metal development of software. So what I did is I took his code, I removed all those knobs because I don't need them in my approach. So we have this hello ASM file. So this file is ready to be compiled. So I have this batch file, and you can reuse this batch file yourself as well. It simply compiles the hello ASM file into a hello binary. For the resident monitor, we need a hexadecimal or Intel hex format of that file. So I'm using this command line here to convert it into the correct format, and that gives us this hex file. So let's try to recompile. So I'm just going to run. Let me bring it to your screen. I'm going to run this batch file. No errors. File has been converted into hex. A new version is here. So I'm also adding an extra line. I'll show you later why. But that's the file in Intel hex format. So that's the binary in the Intel hex format. Intel hex format is cool because it has addresses where the code is supposed to land. It has then the actual equivalent of what the binary would be, and there's a checksum on every line. So every line can be uniquely verified for correctness. So with all this, what we can do now is we can go to our monitor software. We can highlight this, copy it, and we're going to paste it in. But before we paste it in, I just want to show you one more thing that is really important. So in the serial port setup, and specifically for that reason, I'm using TeraTerm as the console software. In TeraTerm, you can set up a per character delay. This is required because, of course, even if I set this speed to 111000, most of the drivers or most of the chips, hardware chips for serial, including the USB to serial adapter that we are using, they don't support this speed. We know that if you send a single character to Nabu at faster speed, so like 112,500, it will take it. But the more characters you send in one go, the bigger chance is that the two computers, your computer and Nabu, will get out of sync. And to help it keep it in sync, we can add this delay in between characters. So that's what I'm doing here. So with this settings in, like I said, copy the file, right click, and it will start uploading or start copying this code into Nabu. And this is Nabu responding. I mean, we don't see any errors. That means that it's taking the hex code in and processing it and accepting it into memory. And that's what we want. That's exactly that means that all the checksums were correct and our code uploaded no problem. So with this, what we can now do is let me show you Nabu. So we know the code was compiled starting at address 140D. So with this command starting with letter G, we will instruct the monitor to actually execute or start executing from address 140D. And when I hit enter, as you can see, it goes straight into displaying the hello world message. So that's exactly what we wanted to do. We have very low footprint firmware monitor in the Nabu. We're able to upload hex files into it. In this case, I have to use teraterm to introduce that 1 millisecond delay. I'll try to later prepare maybe a Python script that can do this for us automatically, so we don't have to go through teraterm, and we can just use Python to add that extra delay in between the characters to automate the whole thing. So this way you only need to execute this batch file once, and it will compile and upload it for you, and even start or execute it in Nabu. So that's I think that's one one interesting way of using Nabu. People ask me about the possibility of replicating the adapter, the small converter that I'm using in my Nabu. So I know not everyone can be bothered to do this sort of. Let me just bring you to the full screen. To do this sort of playing with breadboards and playing with those type of PCBs, it would be nice to have a proper PCB to do it. So I designed a quick PCB in KiCad. I sent files to be manufactured. I will have some PCBs later to play with. This is how it would look like. In fact, I'm teasing with the idea of doing the same thing, and I've started playing, doing the same thing with Wi-Fi connected Nabu. So that's another version of the adapter, but with this ESP8266 converter, so that we could even skip the USB cable. All those will support the resident monitor, so that's a useful thing to have. So I hope this was useful. Of course, my contribution here was to use all of this stuff and kind of put it together as part of this, how you can do a hello world. Credit, of course, goes to people like the team behind Nabu.ca. And this person, whoever this person here, if you're watching, let me know your name. I would love to know who you are. But this was also an amazing piece of work that I've used. So I hope this was useful. Thanks for watching. Thanks for joining me here tonight. And I hope to see you on the next one. If you haven't yet subscribed, please do so. You'll get a notification of any upcoming videos. Thanks.